Let's take a look at adding and subtracting radical expressions with fractions. Now, radical actually just means like there's a root in it. So here's an example. Let's say you've got square root of 2 square root of 2 over 5 plus 3 square root of 2 over 5. Okay, so there's a lot going on here, which makes it seem confusing to some people, but it's really not. It's still just normal adding of fractions. In this case, I made it so that the denominators match, so we don't even need to work that. So when you add fractions, you keep the denominator. So the denominator is 5, but you add the tops. So the 5 plus 5 we don't add. That just carries over. The tops we add. 2 square root of 2 plus 3 square root of 2. This is the radical, by the way. Root 2, the square root of 2, is called radical 2. It's just a synonym for that. So 2 square root of 2 plus 3 square root of 2 is actually 5 square root of 2. We treat the square root of 2 almost like you treat a variable. You know, 2x plus 3x would be 5x. So you treat the square root of 2 like a variable. In other words, we're not saying square root of 2 plus square root of 2 is square root of 4. It's not. It just stays the same, and you're adding them up like 2 apples plus 3 apples is 5 apples. So now, whenever you end with a fraction, it's always a good idea to reduce if you can. In this case, 5 over 5 is going to cancel. 5 over 5 is 1. So that cancels out, leaving me square root of 2 as the final answer. Now, if I'm going to subtract, it's going to be the exact same thing. I'll do one real quick. So if you have 3 square root of 5 over 2 minus 2 square root of 5 over 2, same thing. The 2 you bring over. 3 square root of 5 minus 2 square root of 5. 3 minus 2 is 1. You keep the square root of 5. It's like 3 apples minus 2 apples is 1 apple. That's how you treat the square root. So we have 1 square root of 5 over 2, and that's fine. That's a final answer. But you can also just write square root of 5 over 2 because the 1 we don't really need.